series is organized with an aim to showcase success stories of CSIR during its profound service of 80 long years to the nation and also to celebrate India's Azadi Ka Amrit Mahotsav, that is 75 years of Indian independence. Today's success story is from CSIR National Geophysical Research Institute NGRI situated in Hyderabad. Since its establishment in 1961, CSIR NGRI is actively working on creation of technologies and knowledge base in the fields of geodynamic evolution of the earth, exploration for natural resources and earthquake hazards. So along with the 80 years of CSIR and 75 years of Indian independence, this year holds another significance for CSIR NGRI as it completes its 60 years of establishment. So many congratulations to the laboratory for the landmark achievement. The day today also marks an importance to all the engineers across the nation as September 15th is celebrated every year as Engineers Day in India to mark the birth anniversary of Sir M. Vishweshwaraya, a Bharat Ratna and a great Indian civil engineer. A happy Engineers Day to all the hardworking engineers out there. So for the talk today on airborne geophysics, which is a method to perform geophysical surveys for varying applications using sensors mounted on aircrafts. We are joined today with experts from CSIR NGRI, Director Dr. V.M. Tiwari, Chief Scientist Dr. Ajay Manglik, Senior Principal Scientist Dr. Subhash Chandra, and Senior Scientist Dr. M. Prashanti Lakshmi, all from CSIR NGRI. We are also joined with the stakeholders who are associated with NGRI and are benefited with the technology. Dr. R. Mamalan, Atomic Minerals Directorate for Exploration and Research, Department of Atomic Energy, Hyderabad. Shri G.L. Meena from Central Groundwater Board. Mr. Dharmesh Bhagwagar from Surat Municipal Corporation and Mr. Ajay Dangwal from Rail Vikas Nigam Limited. I am Dr. Shikha with you, your host for the day and scientist from Science Communication Directorate at CSIR headquarters, and I welcome you all once again for the webinar. So we shall start with the opening remarks by Director CSIR NGRI. So before that, I will take few minutes to introduce our audience, Dr. V.M. Tiwari. Dr. V.M. Tiwari obtained his postgraduate in geophysics from Banaras Hindu University and PhD in geophysics from NGRI BHU. Dr. Tiwari has made unique and sustained research contributions towards inferring structure, properties, tectonic, and hydrogeological regimes of the Indian lithosphere and adjoining regions from multi-scale gravity data using physics-based model. He is a recipient of several awards, including National Mineral Award by Ministry of Mines. Dr. Tiwari is an elected fellow of the National Academy of Sciences in India, Indian Academy of Sciences, and also the Telangana Academy of Sciences. He is also a member of several national and international committees. So with this, I now request Dr. V.M. Tiwari, Director CSIR NGRI, to kindly deliver the opening remarks, giving us a brief overview on the accelerating socio-economic growth through airborne geophysics. Over to you, sir.
Thank you, Shikha. Very good morning, namaskar, and greetings to all of you on Engineers Day. We are today assembled to celebrate Azadi Ka Amrit Mahotsav, a tribute to our freedom fighters and freedom movement, and also to celebrate the struggle for independence, ideas of 75 years, achievements of 75 years, and action of 75 years, and so on. In this regard, Ajay, could you please upload the slide?
And I'm just uploading the slide. It's being uploaded.
In this regard, as Shikha had mentioned, we are briefly going to discuss what did CSIR NGRI achieved in last, particularly in 55 years, in initiating, developing, designing, implementing, and hand-holding with the different stakeholders for delivering the science towards the benefit of society and economic growth of the country. I would briefly talk about what do we do, and then my colleague, Dr. Manglik, will present the history, how the geophysical, airborne geophysical observation, in fact, is started in the country, not only at NGRI, but in the country itself. Then it will be followed by my senior colleague, Dr. Prasanthi Lakshmi, its application for the mineral exploration, and as well as the colleague, Dr. Subhash Chandra, will be discussing about the application of airborne geophysics for exploration of groundwater, aquifer mapping, and so on. It's really fortunate to have very distinguished colleagues of different departments and ministries today. From Department of Atomic Energy, the Additional Director of AMD, Sri Mamlam Saab, and Sri Meenaji from Central Groundwater Board, Ministry of Jal Shakti, and Ministry of Railways, we have Sri Vijay Dandewal, and Municipal Corporation of the Surat official we have today, with whom we have been working for last couple of years. Ajay, could you upload the slide?
I uploaded some issues. I think I don't know why this is not uploading. I had uploaded it already.
I think it's not seen. So can you?
Again, I'm trying.
It had come, but again unshared.
Yeah, I'm just uploading once again. It.
So, see, we are discussing the success story on the airborne geophysics, a primary and promising science and technology tool for growth of socio-economic development, and particularly the work carried out by CSIR NGRI, a leading geoscience institute which has been advancing geophysical sciences in the country and made its mark globally. Next one, please. So just to brief about the geophysical world, particularly the airborne geophysics. Here we use the different kinds of the sensors which provides the information about the conductivity of the subsurface rocks, susceptibility, rock density, and the concentration of the radioactive elements. And based on this, we apply these information to know about the oil and gas exploration. We also undertake these surveys for the engineering applications, geothermal mapping, as well as finding out different geological features like faults, dikes, silts, kimberlites. Like kimberlites are one of the source for the host of the diamond, and finding out the paleo rivers and so on. So this is one of the very potential tool to quickly map a large region in a very effective manner. Next one, please. So at CSIR NGRI, the history started in 1960, and we had in the late 70s the first flight undertaken by CSIR NGRI, and it was the first airborne geophysical instruments flew from the soil of the country. Over the decades, the The technologies have been maturing and they have been utilized for the different purposes. For example, the kimberlite exploration for the NMDC, large mapping of the region, working with the Geological Survey of India, and other industry and strategic connects. Since last about a decade, we have been much more aggressively working with the different ministries, departments, and other stakeholders for the different applications, considering the fact that today CSIR NGRI is fully equipped with the state-of-art observational systems and empowered by the dedicated team of the scientists with expertise in the data acquisition, quality check, processing of these data, modeling, integration, and interpretation of these observations for the subsurface explorations, particularly for natural resources like minerals and water. If we see a pyramid, this is we put our stakeholders, means the application on the top, through creation of the value and innovation with the international collaboration and with a very strong team of researchers and young professionals having the experienced scientists uh, to support and back up the initiatives in order to do the projects related to the infrastructures, aquifer mapping, uh, and presently we are having programs connected with the three ministries, five major infrastructural companies, and several other important uh, connecting programs for the national importance. You can see in the photographs where recently an MOU been signed with Central Groundwater Board in the presence of three honorable ministers and two secretaries, Department of Scientific and Industrial Research and Ministry of Jal Shakti. Can you go to next slide? I just thought to bring your also attention towards a very recent thing happened in the Chamoli region of the Uttarakhand, where a large number of people were trapped in the tunnel, and we were asked to find out whether the tunnels were filled with water or not. And within 48 hours, our team flew and could do the mapping of the tunnel in a very short time. The message what I wanted to convey through this slide is not only this technology is useful for the purposes of enriching our knowledge of the subsurface for the exploration of the natural resources, but sometimes they are also used in a very short notice to map very strategically important work and the things which are very important socially. So with this, I wish once again all of you very good Engineers Day. The civil engineers are very close to the geophysics, and I request my colleague Dr. Manglik to further take up the journey of CSIR and GRI in airborne geophysics. Sikha, it's over to you.
Thank you very much, sir. Thank you for the welcome and giving us a brief overview on the technology, its application, and its importance and impact in the country. So we shall now move to our speakers to know more about the technology, its development process, the significances, and furthermore on the application areas. The first speaker for our webinar is Dr. Ajay Mangalik, Chief Scientist and the Head of Airborne Geophysics at CSIR NGRI. He received his MTech in Applied Geophysics from University of Roorkee in 1988 and a PhD from Osmania University in 1994. His research interests are in the fields of computational geodynamics, tectonophysics, and electromagnetic geophysics. He is a recipient of Alexander von Humboldt and Max Planck fellowships, besides some other prestigious recognitions. So I invite Dr. Ajay Manglik to kindly inform us more about more than 50 years of the journey of this airborne geophysics at CSIR NGRI and in India. Over to you, Dr. Ajay Manglik.
Thank you, Dr. Shikha. I welcome all the participants who have joined this session over various online platforms. Welcome to you all to this brief journey of NGRI from its inception to over 50 years. In fact, airborne geophysics has been a very, very important tool, and knowing its importance, especially after Second World War, uh, there was an impetus to start airborne geophysics at NGRI right within the first few years of the creation of the institute itself. And what I show here is that with the visionary director of the then director, Dr. Hari Narayana, who took initiative and initiated this group, one of the early groups of NGRI, way back in 1966, under the leadership or headship of two stalwarts, Dr. P.V. Shankar Narayana, who was a geophysicist, and Professor D. Gupta Sharma, who was from instrumentation. Both these arms are very, very important to conduct any geophysical exploration. This is the teamwork. And what I show to you here is within a year or so, NGRI conducted the first airborne survey in 1967 itself in one of the iron ore belt called Kudremukh Kodeware belt. And just to bring in this historical perspective, I show the first aircraft and the first team who conducted the survey. That time it was a Dakota 3 aircraft, fixed-wing aircraft, where proton precision magnetometer was used to, and radiometric was used to acquire the first data. Immediately after this, NGRI took it vigorously, and over the next 10 years, there were several surveys, exploration surveys for geological mapping as well as for mineral exploration. And this activity went hand in hand with instrumentation development, because globally also instrument development for airborne electromagnetics itself was in infancy. So the institute within the first year developed magnetometers like proton precision magnetometer, medium vapor magnetometer, and fascicle magnetometer, and something which was very important, which was developed in the institute indigenously, was pulse transient electromagnetic system. This is one of the early systems globally which was developed here. So initial 10 years, the institute took it very vigorously, both on the both fronts. And I take a little bit more on this journey to you, basically to give you the entire spectrum of airborne geophysics activity in the institute, starting from 65, 67, which I've shown here. And slowly we move to development of instruments, magnetometer, and this pulse transmitter electromagnetic system. From this one, over the years, NGRI adopted new technologies which were coming up in this field. So basically to provide solutions in exploration in terms of adopting new sensors and integrated geophysical approaches, as well as using new and better platforms, which had their advantages, like bringing sensors very close to the ground and fly. And what you can see here is that somewhere around 2003 onwards, there were upgradation on fixed wing aircraft with frequency domain electromagnetic system. What you see here below is the flying of this frequency domain system. At the same time, Airborne magnetics also took up very vigorously, and this continued. And what you see again is around 2010, 2009 to 10, Institute took another leap forward, basically by taking up new developments in transient electromagnetics, where the big loops, giant loops, are flown below helicopter, and basically two major systems which are available today. One is the VTEM by Geotech, and another by SkyTEM or IOS system. Both are being deployed by NGRI for detailed exploration of minerals in groundwater. Very recently, NGRI also took up the challenge of developing airborne, drone-based electromagnetic and magnetic system. And what you see here is that this is one effort now to do drone magnetics. This is where we are moving ahead. And while moving both on sensor technology as well as on platforms, a lot of work has been done for different government agencies, for governments, for research institutions, and for companies. In between, also, NGRI conducted a survey in 1987-88 in Antarctica, heliborne magnetics. Also, there was a small effort also to initiate airborne gravity and gradiometry in India. While doing these things, I would like to show here the map where different parts of the country, the institute has worked mainly for geological mapping initially by aromatics and radiometric, then magnetics and radiometric, magnetics and fine frequency domain electromagnetics, then moving on to multi-parametric systems involving transient electromagnetic, magnetic and radiometric systems, and then moving on to different applications. Besides mineral exploration, also a new initiative has been to use this for infra projects. And in this journey, we have acquired about 4 lakh line kilometer of airborne geophysical data surveys, out of which, as the director, our director has mentioned that in past 1 decade, we have taken it very vigorously. So you can see that out of this one, 1.77 lakh line kilometer we have conducted by heliborne transient electromagnetic in different parts of the country, especially for mineral exploration, groundwater exploration. To give a few examples of these results, what you see on left panel is a aromatic map of Katappa Basin. It's a Proterozoic basin, which was done in collaboration with Geological Survey of India, somewhere in 1978 to 82. What you see in the center is a high resolution aromatic map of diamond exploration in Kimberlite area for NMDC in 2003. Here we have flown magnetometer very close to the surface by helicopters. Then third development you see around 2005, this frequency domain electromagnetics was used along with magnetics for base metal mapping. This, in the past over 1 decade, we are very actively working in collaboration with Atomic Minerals Directorate for uranium exploration in different parts of the country. And what you can see is that there are different regions, for example, Singhbhum, Satpura, Chhattisgarh, etc., etc. So we are working with AMD for expediting uranium exploration in the country. In 2012, there was another big jump where NGRI initiated a program of groundwater exploration using heliborne transient electromagnetics. And this was the first time in the country when heliborne electromagnetics was used for groundwater exploration. To see its efficacy, initially, first 3 years, NGRI took up a work in six different hydrogeological terrains to see the efficacy of the method. And what I show here is you can see that with this technique, we can see multi-aquifer system as well as paleo channels and connectivity of different aquifers. Details will be discussed by my colleagues, Dr. Subhash Chandra. There was another application of providing water in Surat city. So basically, they have something called French well. French well is something like these wells are drilled on riverbed itself to draw the water from aquifer and supply to the city. So there was a requirement of finding new sites along the river which could be promising. And here, what you see below is an image of near surface of electroconductivity obtained by heliborne transient electromagnetics by NGRI. And this has helped in identifying new locations for new French wells. Very recent application is in terms of doing heliborne electromagnetics for infrastructure projects, basically to to map probable fracture zones, weak zones, etc. along tunnel elements to help facilitate the safe tunneling. And recently, NGRI has conducted one such work for Rail Vikas Nigam Limited, and there are a few more are in offing, which we'll be taking up. At present, the NGRI is engaged with a mega project on low altitude heliborne multiparametric surveys for uranium in collaboration with Atomic Minerals Directorate. This is the idea here is to cover 1.25 line kilometer in over a period of 5 years in promising basins. And when I say sponsored by Atomic Minerals Directorate, let me say this is not simply sponsorship. In fact, this symbolizes our long association between these two organizations, which also dates back to the first flight that NGRI took in 1967. So we have very long association of same 50 plus years, and we are working together in tandem for the uranium exploration. As our director has also shown about MOU signed between CGWB and NGRI for a major program for groundwater exploration in different arid regions, semi-arid and semi-arid regions of the country, where the plan is to cover about 1.5 line kilometer in phased manner. This is done with the initiative with the Ministry of Jal Shakti, and this program is also on, which we are taking up. While doing exploration, a few years back, NGRI initiated a program on development of drone-based electromagnetic and magnetic system, acronymed DREAM. This is a pan-CSR initiative where three other labs from CSR are involved in this development, and this is sponsored by CSIR. Below we see, I show a few pictures showing test flight of drone magnetic system, signing of MOU between CWB and NGRI, and our team for uranium exploration in one place in the India. Thank you very much. This is a brief summary about the evolution of NGRI's airborne activities. Thank you.
Thank you very much, sir, for the talk and giving us a brief overview on the technology of airborne geophysics, its evolution and expansion throughout the years at NGRI. So it's really a very interesting topic to know for all our viewers. So we'll move next to our next speaker, Dr. Prashanti Lakshmi, Senior Scientist at CSIR NGRI. Dr. Prashanti Lakshmi received her MSc in Technology degree in Geophysics from Andhra University in 1999 and PhD in 2005 in the field of aeromagnetic geophysics. She is actively involved in high-resolution multiparametric heliborne geophysical exploration. And in fact, she was one of the lead members in several projects dealing with mineral exploration in general and kimberlite and uranium exploration in particular. So today, Dr. Prashanti Lakshmi will inform us on the transient electromagnetism for uranium exploration using airborne geophysics. Over to you, Dr. Prashanti Lakshmi.
Yeah. Good morning, ma'am. Good morning, all of you.
Dr. Prashanti, you are muted.
Okay. No, sir. It is unmute.
Okay. You start.
Can you see my slides? Sir?
Slides are visible?
Slides are visible.
Slides are visible. Yeah, you can go ahead.
Go ahead.
Yeah, okay. Thank you, sir. Good morning, everyone. Today, I can proudly say that we have been working with the AMD for the last 15 years for the project called Augmentation of Uranium as a cleaner energy source. So here I can show you a quick glance of how transient electromagnetic methods is useful for uranium exploration.
Ma'am, you can make it full screen.
Is it not full screen?
No, it's not.
Here it is full screen.
Oh, okay. It's fine.
Okay.
Yes, sir, it is full screen.
Yeah, it's full screen, ma'am. Please continue.
Uranium is a natural element abundant in felsic rock like granites and pegmatites in few parts per million, 2 to 4 ppm. It is really readily leached and easily oxidized to a water-soluble form during the oxygen-rich geological periods. transported away from the source rock and redeposited in sediments and other favorable structural features at large distances from source rocks when it encounters a reducing environment. So the source rock, reduction oxidation potential, host rock mineralogy, and structures that act as pathways for uranium-rich solutions to pass through are the basic factors that control uranium mineralization. Uranium occurs in number of geological environments. This diagram shows a schematic representation of various geological terrains and environments in which uranium is found. For example, these are the veins which are deposited in fissures and fractures of a metamorphic rocks, and this is an example for unconformity related uranium at the base of the proterozoic sediments above the metamorphic basement along the fractures and shear zones, and within the sandstones of Mesozoic sediments, whenever it encounters a paleochannel of carbonaceous matter, phyllites, etc., it will be precipitated in the sandstones. These are the relatively shallow and younger sediments. And another one is the quartz pebble conglomerate type, where uranium in the nearest rocks, source rocks, will be disintegrated mechanically and deposited at the paleo valleys as a placer deposits.
Prashanti, is visible? Second slide. Dr. Prashanti,
Still in first slide.
Is it okay?
I'm distant first slide.
Oh. I'm unable to go to next slide.
No, I'm moving. You tell me next. I'm moving slide. Next.
I cannot see the slide, sir.
You come here then. Just come to my room then.
Ajay, you cannot see the next slide as well.
You can't see. Is it okay now? No?
No, sir.
Okay, let
No
me
slide.
unshare here again.
Now it's fine. So
Is okay?
can you? No, next.
Okay. This is fine.
It's the same slide moving.
I'll unshare and share again.
Ajay ji, you have to unshare. Actually, na, it is taking screen on the main one. Please unshare and share it again.
That's what I'm going to do now.
Move to next.
Not moving?
No.
Not moving, sir.
I'm unsharing. I think connection is looks like slow. Dr. Shikha, I think let Shubhas take over. He will present from his system. In the meantime, I'll fix it.
Slide is visible now, but it's in first slide only. It has not gone to second one.
I'm trying to stop presentation and share. It does not do here. So something is hanging.
So Ajay, what you should do, you go to the normal mode without slideshow, and they can. Prashanti can. Okay. So go to the next slide, normal way. Your slides are hanged and you are, I think, frozen. So let us.
I think it has come to second slide now.
Yes, sir.
In normal mode, it is coming.
Okay, sir. You can see the second slide now, where there is a map of India.
In
No,
normal mode, it is showing, not in slide share mode.
Can you see the second slide now, madam?
I cannot see. No, it's in first slide only.
I can see the second slide.
Okay, if it is
Now
visible,
it has
please
gone
share.
back to the first one.
Let it be undisplayed, sir. In normal mode, we can see it. This is okay, sir.
Now you can see the second slide.
Yeah, we can see it.
Yeah, it's
better
it's
not to
visible.
go in display mode.
Yeah, okay, madam. Thank you. Sorry for the.
And Prashanti garu, just go to third slide also so that it is going right. Let me check first. Go to the third slide and
Yes,
come back
sir,
to
I
second.
have gone. I have gone.
Yes, perfect. Go back to now second. Yeah,
Yes, sir.
please continue. Right.
Yes, sir. Okay, sir. In India, uranium occurrences were reported in proterozoic basins and phanerozoic basins and large crustal scale shear zones. Uranium deposits occur in major crustal scale shear zones like Singhbum shear zone and the Albitate zone in Rajasthan, and proterozoic basins like Kadpa basin, Bhima and Kaladgi basins in Karnataka, and Chhattisgarh basin state of Madhya Pradesh and Chhattisgarh, and Mesozoic basins like Mahadek basin and Satpura basin in various parts of India. Discovery of bean-time mineralization succeeded in 3 provinces: Singhbum shear zone and Lesser Himalayas of Uttarakhand and Albitate zone. So, uranium is an atomic mineral that is radioactive and emits gamma rays continuously, by virtue of which we can sense the gamma rays and uranium mineralization directly if the uranium is at very shallow levels. If it is covered by a pile of sediments, then we cannot sense the gamma rays because they decay fast. So in this case, time domain or transient electromagnetic method helps in a great way, where we can find out the environments where uranium will be deposited. These are very favorable for TM methods to explore, because all these are environments are relatively conductive in a range from wide variety of conductances. So the main principle of this TEM method is there is a transmitter coil and a receiver coil in the loop. This transmitter is energized with a alternating current of low base frequency. This primary current is interrupted abruptly after some time. This sudden change in the primary field causes creation of eddy currents initially at the surface of the conductor, and they start dissipating downwards. When these are changing, the associated magnetic field also starts decreasing. The rate of change of this secondary field is measured over a predefined time gates and plotted as a decay. This whole process of excitation is repeated several times per second, and the data are stacked for a given location. I will show you some examples of conductive sources which are mapped exclusively for the uranium exploration. This is an example of North Singhbum shear zone, where the upper right image shows the TMI, total magnetic intensity anomaly image. It helps in mapping the faults, fractures, etc., where there is a possibility of uranium-rich minerals to be precipitated. The below one is one of the time gates from the decay. I think this is channel 20 image. And left hand side, you can see the mafic body mapped from the magnetic data, and the below one is the 3D picture of the conductivity, where uranium mineralization is associated with carbonaceous phyllites and sulfides, other sulfides. This body is exactly correlated with the drilling results, where they have met with carbonaceous drilling has met with carbonaceous phyllites in this region. This is another example from northern part of Kadpa basin, where huge sources of uranium are established. In the upper left corner, you can see a negative decay. Sometimes these negative decays are very useful. Where there are some material like disseminated sulfides, etc., they are energized, and when the current is switched off, they act like batteries, and the rate of decay of that secondary magnetic field will go to negative values. and we will get a negative decay. In the below image, you can see how clearly the unconformity below the sediments above the basement is mapped, where occurrence of uranium is established. The right one is the average of the several time gates shown in a single image. The white ones are the zones of uranium mineralization, established zones of mineralization. You can see a direct link between the mineralization and the negative responses. This is another example from Madhya Pradesh over a collapsed breccia type mineralization. This is called Mohar Cauldron. It's a felsic volcanic event where igneous intrusive bodies are erupted. It is located in Madhya Pradesh with 7.5 kilometers dia and 4.5 kilometers dia of younger sediments in the center, surrounded by a ring of 3-kilometer collapsed breccia. There is a possibility of uranium and other multi-metal deposits present in the collapsed breccia, overlying the opening of the explosion. These circular features in red color are the breccia, collapsed breccia mapped at different depths. They have established 2 new intrusive bodies which are underground, not exposed on the surface, and the extent of sediments in the first image, in the upper left image, you can see CDI, you can see the extent of sediments. In the middle one, you can see the dispersion of different layers of sediments, and the below one, the 3D representation of entire geometry of the cauldron are mapped up to 500 meters. These images are from Bhima Basin. I'm not sure of conglomerate type of mineralization here, but this is the best example where we can map the basal conglomerate just above the basement, below a thick pile of 350 meters of sediments. You can see in this CDI image, you can see the bottom of the sediments. The above one is the conductive layer, which confirmed in drilling that it is a conglomerate bed. So these are the very few examples from the available literature, because we cannot show our results actually where we are working. Thank you so much.
Thank you so much, Dr. Prashanti, for your talk about the process of uranium exploration using technology of airborne geophysics. So we will quickly move to our next speaker, Dr. Subhash Chandra, Senior Principal Scientist at CSIR NGRI. His research interests are in the fields of groundwater, airborne electromagnetics, and aquifer mapping. Dr. Subhash Chandra has several research publications in peer-reviewed national and international journals. Dr. Chandra is a recipient of Boycost Postdoctoral Fellowship and the National Geoscience Award of 2017 in the field of groundwater exploration. So with this brief intro, I invite Dr. Subhash Chandra for kindly sharing information and experience on application of airborne geophysics technology for rapid groundwater exploration. So over to you, Dr. Chandra.
Unmute your mic, Subhash.
Unmute your, please.
Thank you, Sikha. I hope my presentation is visible.
Presentation is visible. Yeah.
So already it has been briefed that we started the groundwater, the application of airborne geophysics in the field of groundwater in 2012 with the Central Groundwater Board, where we have taken, in fact, the 6 typological area representing different hydrological settings, starting from desert in Jaisalmer, and then followed by Dausa district, where alluvial covered overlays or the hard rock, and then Ganga plain at Bihar, where the arsenic problem is there, Deccan Trap, which is known for the water scarcity, then crystalline hard rock, the Tumkur district, and then Tamil Nadu coast. And idea was to establish the mythology and then upscale to the regional scale. After successful completion, we have moved to the Paleo channel near Prayagraj, where we have discovered a Paleo channel, and then also applied for the Surat Smart City for smartly managing the natural resources, and then also moved to the tunnel application. And now we are set for a mega project for aquifer mapping, starting from Himalayan foothill in Haryana, Punjab, via Rajasthan, go to up to the run of Kutch in the Gujarat. So 4 lakh square kilometer area we are going to cover in the 2 phases for providing the geoscientific solution to the water problem. Why this rapid? Because the helicopter system, like our transient electromotive system, is hanging 30 to 40 meters below the helicopter, and helicopter flies at the 60 to 150 kilometers per hour. And that provides the data at every 2.5 to 3 meters, which we finally process and come out with a 1D model at every 25 to 50 meters along the flight line. So, and then putting all together, we get a 3D model. For example, this is the flight line, and there could be some few tie line. And each data actually have a data where d by dt response with the time provides the ratio information with the depth, and that is subjected to the advanced processing, where depending upon the geological continuity or dense continuity, the constraints are maintained to provide a more represent a more hydrogeological settings of the area, and then finally come out a 3D model where these ratio models can be sliced in any direction, horizontally, vertically, or at certain angle. And each dot points again gives a ratio distribution with the depth. Ratio is a cumulative effect of physics and chemistry of the formation, and physics like what kind of geological materials are there, and whether moisture is present, and what kind of quality of water is present. So these kind of information we can take out by translating in terms of our parameter of interest with certain, of course, the input. In the pilot project, we have not applied only the Airborne Geophysics, but also carried out number of classical method where vertical electrical sounding, ground transient electromagnetic, ERT has been applied, and these are actual data has been actually what we try to put that what is the production rate, and these are the number of days, like 129 days to taken to acquire 259 of the data. So if you transform this data in terms of production rate, per day we get almost 2 sounding, and then 6 ground transient electromagnetic sounding we can cover in a day, depending upon, of course, how much distance we are covering. And then almost 147 equivalent 1D point from the electrical ratio tomography, and more than 4,000 we get in a day. The 1D model from the Airborne Geophysics. So suppose we have to cover in a water set where the 10,000 points are needed, it may takes more than 4,000 number of days, whereas the same kind of work can be acquired in a few days by the Airborne Geophysics. So that such that it is very fast, and then the accessibility. So like ground geophysics, it faces the biggest challenge of the ground accessibility. Sometimes the fencings are there, sometimes ground does not allow. So Airborne, it becomes very easy and accessible and cover the regional area to give a holistic picture. How dense data should be there. So suppose this is the conceptual model, and if we look for the groundwater, we try to do the pattern recognition, and the lineament become the first target to find out the lineament or such feature, whether localized body or linear body, or how long it is extending. So we take certain observation point and try to see the pattern recognition analysis. And suppose these are the 2 kinds of the dots, and anyone can have a best possible model connecting all those things. And in case of lineament, we can talk about this could be buried channel or some other lineament. But by increasing the more data density, we can have a more control to refine our model. And now you can see that the same data, now more data, by increasing the data density, our model become very constrained and getting a more realistic information than the few scattered point, because more degree of freedom is there if you have a less data. So optimal data density is very, very essential to come to a realistic conclusion. One of the pilot area was in the Ganga plain, Patna, Bihar, which is affected by the arsenic contamination. And we all know that arsenic is very burning issue, started from Bangladesh. Now it is coming up very rapidly in the upstream region, Patna, Balia, even the part of the Uttar Pradesh. They are affected by arsenic contamination, and by lowering the water table, it is further accelerating the spread of the contamination. The area what will flow, it is at the confluence of Ganga and Son. And Son has been known for moving from east to west and leaving the paleo channel in the east. And we can see here, this is the paleo channel of the Son, and this is the first principal aquifer. This is second principal aquifer, and they are interconnected. So the connective, and this is a place known for a new tectonic activity. So such a small things also we can get it. The important thing was interconnected. But then looking at this level, we see that paleo channel may be or may not be connected. And since we have a 3D model, we have a free, opportunity to cut it, slice it at different angle, and then we can see here this. These are the paleo channel is interconnected with the first principal aquifer, and then the first principal aquifer is connected with the second aquifer. So in case our arsenic contaminated zone is located nearby, this may, this connected pathways may facilitate for a rapid spread of contamination to the deeper level, which has been the case in the Bangladesh. There has been vertical percolation of the arsenic contamination to deeper aquifer, because the people started exploiting the water from the deeper aquifer, thinking that these are the fresh aquifer zone. So one thing is that there is a strong need of having a knowledge of the clay distribution that acts as a controlling parameter to the arsenic contaminant spread. The second, for the management aspect, maintaining the hydraulic gradient between the piezometric level that comes from the confined aquifer and then water table, which is from the unconfined aquifer. So maintaining hydraulic gradient become very important thing, which was disturbed in case of Bangladesh, in fact. So suppose we start pumping from the deeper aquifer, and this is the first principal aquifer which is contaminated by arsenic, and this is second aquifer which is free from contamination. And if you start pumping and heavily pumping for a long time, this piezometer, which comes from the second aquifer, if it comes down below the water table, there will be a vertical, downward hydraulic pressure from top to the bottom. And then in case of this, the leaky aquifer like silt, etc., they become, active for avoiding, allowing the vertical percolation of contaminant. So knowledge of the clay, and then where is the weak zone and what is the hydraulic gradient. So these are very crucial for managing the groundwater resources in such affected region, become very crucial. And if you make a dual pumping scheme where you pump in such a way that both move together, then at least you can avoid vertical percolation, and then this leaky zone can be still acts as a impermeable layer, avoiding the vertical percolation of arsenic contamination downward. If you see the result of DOSA distribution comes in the Aravalli hill range, there is an alluvial covering over the quartzite hard rock. Of course, there are a small portion of the granite also. So this purple color, it can be seen very clearly. It is a bedrock, and then green to blue color or yellow color is actually representing the alluvial. Within the alluvial also we can see there is the yellow color shows the sand. Here also sand. There is a structural discontinuity. So along this you can see there is a vertical dislocation of the sand layer itself. And the same thing can be seen in the deeper level. There is a DOI line that shows the weakness. The fracture or tectonic activity within the quartzite, which has created a weakening. So such a small detail can be obtained from the from the airborne. And then since we are getting a low moment, high moment together, ensuring the information from top 1 meter to 1 to 2 meter to the deeper up to 500 meter with the latest system, which has got 5 lakh NIA. And then we can quickly get a 3D view at a watershed or basin scale to have a more effective management plan. These results have been validated by ground-based measurement, where borehole geophysics has been carried out, as well as there are lithologs, which comes from the drilling, and there is a very strong corroboration and validating. The aeromagnetic survey, the result shows that disconnecting in the folding structure within the basement rock, how they are folded, and this area is known for folding and faulting. This is the resistivity map derived from the transient electromagnetic survey, and if you take the profile line, vertical section, this is resistivity, and then interpreted hydraulic model that shows the lithology as well as the water content. So these are the faulted zone, and then this fault zone create a weak and then enhance the porosity and where water occurrences take place. So, and this has been published in leading edge. So these are the proven results. Coming to the Surat smart city, this area is located at the sea coast. So, and the population is growing very rapidly. So, increase in the population, that means there is a increasing demand of the water, and manage and then supplying the water, safe water to the Surat municipality, the Surat population become one of the challenge. And SMC did very nicely that they started utilizing the river water through the French well, where the radial well is planted into the river bottom, and where the sand at the bottom acts as a filter to the river water, and then and those water they pump it and supply. So it saves the cost of the filtering as well as ensures the water, good quality of the water, and then avoids the seawater intrusion as well. But then, what is the how good sand quality is there, and what is the 3D volume that sets its sustainability? So in order to get this information, not only within the river, but then adjoining area, how much connected, what is the connected discharge from the Tapi, and in drought condition, how it can be used. So for this smart application utilization and maintaining the sustainability, airborne survey was carried out. And you can see this is the high resistivity zone that shows the large granularity, means sand, and these are the barrage, and there is a reverse seawater bag, so there is a salinity which can be seen in the blue color. And if you see the profile along this river up to here, these are the zones, these are the sand piles. This so there is a sand mining area. So not necessarily all along the river there will be good quality of sand. So somewhere it is a larger size, somewhere it is a smaller size, and this information we have got in 3D. So that provides a good site for the French well, and even it ensures the sustainability. And then even the deeper zones are connected. So where it is recharging in the worst condition in the future, if for continuous year there is no rain, these zones can be tapped for exploiting the water. So that was a very innovative plan. Even this barrage which currently is here, it is planned to be taken here. And these are the already hard rock, this purple color zone, and this Tapi river. So if you construct a artificial kind of dike of 500 meter length, that become effectively a few kilometer long, and that will be much more powerful than the current barrage over here. So this is going. This is another application of this airborne survey, and SMC has been given a FICCI award, the first prize for water security, for scientific application of scientific innovation toward the water security. This is my last application, the last slide, where it has been used for tunnel related work in the Himalayan foothill for RVNL, Rail Vikas Nigam. And this is the tunnel which starts from the surface, but then very soon it enters into the hills, where a kilometer high hills are over there. So huge overburden, And then if they stuck to the water-bearing zone, that can have a threat to the life as well as machine, and then a stoppage of the work, of course. This area is known for a structural discontinuity, you can see here, and then that is very well responding to the by the resistivity measurement. So lowering in the resistivity, then the host material indicates there is a discontinuity, there is a disturbance, and there is a and then presence of the water. So fracturing, faulting, weathering, and then added water, it lowers down the resistivity in general in the hard rock, whereas in the soft rock it goes in a other way. So these weak zones are presented over here as a Carson area of the Carson, where the the care has to be taken while tunneling. So and this has been done for 126 kilometer long tunnel. So with this, I'd like to thank to the Central Groundwater Board, Ministry of Jal Shakti, Namami Gange, Surat Municipality, Rail Vikas, with whom we have been working, and results have been validated by them. Thank you very much.
Thank you so much, Dr. Chandra, for your talk. So it's really very fascinating to see such kind of airborne activities for water and other resource exploration. Those are based underground. So thank you again. So we are today also joined with stakeholders who are associated with this lab and the technology. So we shall now listen to their experiences and comments on the technology. Let us start with Dr. R. Mamalan, who is Additional Director at Atomic Minerals Directorate for Exploration and Research, Department of Atomic Energy, and a long-time collaborator of CSIR NGRI, as Dr. Manglik informed. So over to you, Dr. R. Mamalan.
Good afternoon, everybody. Am I audible? Hello?
Yes, sir.
Yes, audible, sir.
Yeah, thank you. At the outset, on behalf of AMD, I convey my greetings to all the scientists of NGRI and other participants. A very, very happy Engineers Day. AMD and NGRI have a very, very long collaboration, long relationship. It started, it's more than 50 years of long collaboration. So it started, NGRI conducted airborne, as Dr. Manglik pointed out. NGRI conducted airborne magnetic and gamma ray spectrometric surveys for AMD in a Dakota platform in the year 1967 in the Kudramukh area of Darwas. So we were interested in at the base of the Darwas. That's for quartz pebble conglomerate for uranium investigation. That was the first surveys carried out for AMD. Of course, we were conducting airborne surveys even before that. But NGRI purchased, I think that NGRI purchased a magnetometer at that time, and it was installed in that Dakota aircraft. And along with the gamma ray spectrometer, they flown for us in 1960. That was the first collaboration we had with NGRI. Since then, more than 50 years, they have collected a lot of data, conducted a lot of surveys for AMD, and we are. These are the very basic data sets required for uranium exploration. We are using it day to day. We are using those data sets in our uranium exploration. So in in 2006, AMD and NGRI signed an MOU for heliborne surveys with EM. EM was first introduced during that period. Though we are doing a lot of magnetic and gamma ray spectrometry surveys, electromagnetic surveys were introduced during that period. So we signed a MOU with NGRI for 1,25,000 line kilometer survey. So 20 to 25,000 line kilometer in a year. So like that, for 5 to 6 year period, we have signed an MOU, and that has been very successfully completed. NGRI have done surveys over a number of provinces, and a lot of data have been collected. Actually, for these surveys, NGRI have procured a heliborne geophysical system comprising gamma ray spectrometer, heliborne gamma ray spectrometer, a magnetometer, and transient electromagnetic sensors. This was purchased from Geotech Canada. and they started the surveys with that. Subsequently, in the next year, AMD also had purchased a very similar system, almost the same system. And since then, we are also conducting parallelly with NGRI nearly more than 3.5 lakh line kilometer of surveys have been conducted, and so much of data have been collected for uranium exploration program. One of the interesting thing here is, these two systems we have purchased from Geotech. Generally, they don't sell these systems because once they sell these systems, they lose their survey contracts. So somehow we have persuaded and they were ready to sell, and we have purchased system. Subsequently, Geotech also sold nearly 6 or 7 systems in other parts of the world. I am given to understand that the systems, nearly 8 or 9 systems, what they have sold to other agencies, only 2 are in working conditions. So that is, one is with the AMD and the other is with NGRI. Only these 2 systems are in working condition, and the credit goes to the very dedicated engineers who are maintaining these systems. So we both the AMD and NGRI, we are backed with a very strong team of engineers, and they are meticulously taking care of these systems. With this system, NGRI have done for us, for AMD. Initially, they have done in parts of Indian and Northerly Pole Belt with Hummingbird system, what they already had. And after 2010, they have done surveys in parts of North Singhbum Shear Zone, Chhattisgarh Basin, Satpura Basin, and presently they are carrying out surveys in parts of Chotanagpur Granite Gneiss Complex. I can tell you this: they have a lot of new areas have come. The areas identified based on these surveys are under drilling, subsurface exploration. A lot of new activities have been brought, and new deposits are coming up in these areas. As somebody has pointed out, I think Manglik has pointed out that paleo channels are identified. It's a very, very innovative using EM data. We have identified the paleo channels in Satpura Basin, Satpura Gondan in Madhya Pradesh. These paleo channels are buried at a depth of 300 meters. And these are braided channels, these unestimation channels, number of, those who have crossed the river Godavari must have seen. It's not completely filled with water. There are number of streams are there. They diverge and connect. These are all unestimation streams. They are called braided streams. This setting is very ideal for localizing uranium mineralization. A particular type of deposit, like sandstone type deposit, are situated in that. So identifying these features are very, very important. We identified using the data accrued by NGRI, and it's all processed by NGRI scientists. They have identified 2 channels, such paleo channels, and these 2 channels are under active exploration. We are getting a lot of mineralization in those channels. Similarly, the Singhbum Shear Zone, they have done surveys for us. Now, in fact, day-to-day work, we are consulting this data. Day-to-day subsurface exploration, we are consulting the EM data and magnetic data of Singhbum Shear Zone, what was collected by NGRI. And presently, they are doing surveys for us in Chotanagpur Granite Gneiss Complex, where number of 4 or 5 occurrences have been identified, and they are under very active exploration now. So now presently, after the first 1,25,000 line kilometer of MOU they have completed, and we have entered into another MOU, under which another 1,25,000 is agreed upon, in which nearly some 35,000 has been completed, and a long way to go. So we have another nearly 90,000 line kilometers to cover under this MOU. Maybe another 4 years, we will be continuing this work with NGRI. Here I wanted to emphasize one thing, as Dr. Prasanthi has pointed out. AIP effect, that is airborne inductively induced polarization. That is one of the effect we observed. It is an offshoot of EM, though the surveys are conducted for to identify the subsurface properties of conductance in various rock types. The IP effect is also negative EM or IP effect. This is one of the important offshoot of this. Though it is not intended, we are getting an additional data. So we are finding now more than the EM, this AIP effect is more important for exploration, especially for metallic minerals. This is a very, very important data. The present, the present configuration of the system specifications or configuration, what is kept for surveys. This the pulse width is 25 hertz, 20 millisecond pulse, and 7 millisecond of on time. With these system parameters, we get AIP effect up to a depth of 100 meter. I am told that if you can meddle with these parameters, we may be able to get even at deeper level, say maybe 200, 300 meter. If you can get, it will be a wonderful achievement. In fact, we ground-based ground-based IP surveys are very, very important for uranium exploration, and we have 7 IP equipments which are deployed in different parts of the country, potential uraniferous zones, and we are doing regular surveys. So I can see with one team of geophysicists and geophysicists, 3 geophysicists and 1 IP equipment, we can cover nearly 10 square kilometers, not more than. It's a very, very cumbersome and very, very laborious jobs. You have to spread the cables, we have to move the generator, and very, very laborious job. Only 10 kilometers we are able to cover in a year, in a field season. So if the same can be achieved by modifying the system parameters through airborne platform, it will be really wonderful. I request Director NGRI to kindly initiate this type of research. We are also doing here. We may have to, by the end of the flying, we may have to change the parameters, devote some time for collection of data. So that's why this one request to NGRI. I think we can, both AMD and NGRI can jointly we can do this experiment at the end of the surveys. So with this, AMD is looking forward to continue our collaborations with NGRI. It will continue in the years to come. So I congratulate NGRI on organizing this webinar, and thanks for inviting me to this seminar. Thank you very much.
Thank you very much, sir, for your talk. And it's very interesting to know the long collaboration of AMD with CSIR NGRI. And there will be many more years to go, I am very sure. So we'll move to our next stakeholder, who is Mr. Dharmesh Bhagwagar ji, who is a hydraulic engineer at Surat Municipal Corporation. So we'll listen to his talk now. Mr. Dharmesh ji. Dharmesh ji, are you there? Is he not connected, sir?
जो पटेल साहब का है ना कनेक्शन, वो उन्हीं का ही है, बट आई अंडरस्टैंड दैट किसी तरह से.
Okay, then we'll move to our next stakeholder, Mr. Vijay Dangwal, Additional General Manager, who is an expert in geology from Rail Vikas Nigam Limited. So can we have some views of yours, sir? Yeah, please go ahead.
Good morning, everyone. And on behalf of RBNL, I wish you all very happy Engineers Day. Our project for which we engaged NGRI, CSIR NGRI is a very long railway tunnel. I mean that 16 tunnels. It's a 125-kilometer long project in the Himalayan terrain. And for designing of the tunnel, the subsurface, the nature and characteristics of the subsurface material is very important, and especially the hydrogeological conditions, which may treat hazards during construction. So we just received the report prepared by NGRI for our project. It's a very good report, and it's very useful for our designing, safe designing. And we found this technique, it's a very useful technique. Obviously, I mean that it's a good technique for future projects. So I thank NGRI because I am in a hurry for carrying out this study for us, and we found this study very useful. Thank you very much.
Thank you very much, sir. Ranji, sir.
Shikaji, you please, Meena, there is Dr. Meena, Shri Meena ji from CGW. Yeah.
Yes, definitely. So we are having our next stakeholder here, Shri GL Meena ji, who is a member of Central Groundwater Board. So can we have a talk of his now? Meena ji.
Good afternoon.
So please. Yeah.
And happy Engineers Day to all of eminent scientists of NGRI and other government organizations. And I am thankful to NGRI for inviting me, and we, CGWB and NGRI has a long association in groundwater exploration. Initially, we have taken a pilot project in 2012 at Rajasthan, some part of the Rajasthan, Bihar, Maharashtra, Tamil Nadu and Karnataka for supplementing our national program, aquifer management programs. And the results of the pilot studies increasing and particularly a very significant in alluvial and desert area. Subsequently, we have employed a helical survey in Uttar Pradesh in the Ganga, Yamuna, Doab regions, covering parts of the Allahabad and Kausambi. And now we are in the agreement for taking up the helical survey for high resolution mapping of aquifers through helical survey, which will help in preparing site-specific plans for management and interventions in the water-stressed area of state of Rajasthan, Gujarat and Haryana. We are going to taken up this program around 4 lakh square kilometers in mostly covering the arid regions of northwestern India in 2 phases. First phase, we are already going in ground survey work, and heliborne survey is likely to be started within a short period as intimated by the NGRI. The first phase, the airborne geophysical survey has the advantage of the faster spatial coverage in mineral as well as groundwater explorations. This provides information about subsurface disposition of aquifers, also provides information for preparation of high resolution aquifer maps, including aquifer geometry with the demarcation of desaturation and saturated aquifers, fresh and saline zones, distribution of paleochannel networks, and also suitable sites for groundwater withdrawal, and for any sites which is required for artificial recharge, and many others. So, airborne survey gives a very good result in the groundwater exploration in there also. Thank you.
Thank you very much, sir. So, do we have Mr. Dharmesh connected with us, or shall we move ahead?
Dr. Shikha, there is Mr. Nilesh Patel from Surat Municipal Corporation. You can invite him.
Yeah,
Mr.
so
Nilesh.
Mr. Nilesh Patel from Surat Municipal Corporation. So, can we have your views, please?
Yes, good afternoon, all of you. Myself, Nilesh Patel from Surat Municipal Corporation. On behalf of Surat Municipal Corporation and specifically from Water Supply Department, I would like to extend a very happy Engineers Day to all eminent scientists over here. As far as water supply management of Surat City is concerned, we are actually managing a surface water-based water supply system in city of Surat. Now, city has witnessed tremendous growth post 90 era, and we are envisaging population of more than 1.68 crore by 2051, as per the census as well as the kind of survey we did. Now it is a bit difficult and it is a gigantic task as far as water supply management in city of Surat is concerned with surface water based only. So in order to create the backup or alternative source of water supply, so we are exploring more and more subsurface kind of water supply system with the help of infiltration well, or you can say the radial collecting well. We were having only one radial collecting well prior the Airborne survey, what we did with the help of CSI, IR, NGRI. And the very purpose of this, this Airborne survey was to create a repository, or you can say the inventory of the surface water, where exactly we can locate the radial collecting well within river itself, so that with minimum water treatment cost, we can deliver water to the citizen of Surat city. And now cities is also vulnerable to the potential effect of climate change. We are playing between two extreme conditions, like drought-like condition as well as flood-like conditions. So we are not worried as far as flood-like condition is concerned, but we are very much skeptical as far as availability of potable grade of water during drought-like condition. So in order to create more and more radial collecting well, the very purpose of this survey was conceived. And second purpose of this survey was to create additional reservoir because city is near to the Arabian Sea. So salinity intrusion is also one crucial aspect. So in order to create additional reservoir along with the recharge, the creation of the recharging condition in ground. So the barrage kind of structure, what we planned with the help of this survey, is also the focus point. So these are the two aspects what we envisaged through this survey, and excellently this data as well as the outcome as well as analysis what NGRI has extended to us is remarkable for the city of Surat. And additionally, this is the new dimension as far as the groundwater as well as subsurface water exploration is concerned. Thank you very much, NGRI, CSIR, for extending all technical and the help for the city of Surat. Thank you.
Thank you very much, Nilesh ji, for your views and talk here. So thank you all for sharing your experiences on the technology and your coordination with CSIR NGRI. We keep this forum open for a discussion among the speakers and the stakeholders. And I shall also take few questions from our viewers. So we have few questions. Yeah, first of all, it is at what depth uranium deposits are generally found? From Dr. Joy Roy Chaudhary. So maybe Dr. Prashanti, if you can provide some views on this.
I think I can answer this.
Dr. Mammal can better answer this question because they come directly from the department.
See, uranium mineralization can occur even at a depth of say 1500, 2000 meter, but you know the depth of exploitation, that is what is matters. No, we cannot do a mine say more than 1000 meters. So that is the limit. Generally, we explore up to say 1200 meter, not below that. Even if you explore a big deposit, it will be very difficult to exploit it. So there are mineralization is possible even below that 2 kilometer or more than 2 kilometer is possible because these are along the structural planes. As a hydrothermal solution moves, so it deposits the mineralization in the along the way. So it can occur even more than 2 kilometer or 3 kilometer. But most of the deposits occur near surface. It's again goes with the age of mineralization. Presently, more than 40-45% of the uranium deposits are exploited from sandstones. These are all near surface, say within 100 meter depth. So 40% of the uranium comes from sandstone type of deposits. Some unconformity type deposits can go up to say it's exploited, mined from a depth of say 700-800 meter. Our own Jadugoda deposit, it's more than a kilometer. We have reached 900 meter. We are going even below that. So it's possible, more than 2 kilometer it is possible. But our limit is, we set a limit of 1000 meter, 1200 meter.
Okay, yeah. Thank you, sir. So we have another question. So Sundar Raju wants to know, can Airborne Geophysics map a rock type, that too conglomerates? So it may relook other sedimentary basins for mineralization like paleoplacer, gold and diamonds, etc. Any views on this?
You want me to take up this?
Sir, please.
Okay. Actually, when we see these airborne techniques, these are basically based on the physics, the background of physics. Everything is dependent on certain laws of physics, and what it depends on the physical property contrast. If there is a physical property contrast, for example, if we talk of electromagnetism, transient electromagnetism or frequency electromagnetism, we look for electrical conductivity. If there is a contrast in electrical conductivity, we can map. Same way, when we look for magnetic property, then we look for magnetic susceptibility in terms of magnetic anomalies. So ultimately, what we look in all these methods is whether there are physical properties contrast or not. If there are physical property contrast, we can do. Yes, this conglomerate deposits, as some of the examples which Dr. Prashanti has shown, that airborne electromagnetics has been used for those kind of deposits for uranium exploration. Yes, this has been done, and certainly this can be used also for sulfide kind of deposits because they also do give good contrast. And as Dr. Mamlan has pointed out, new offshoot of IP. If we can look into these IP effects, in fact, those kind of mineralization we can look into in much better details. So it is possible. Thank you.
Okay, thank you, sir. So I have a few questions. So the sensors that we develop, they are generally attached to the aircraft. This is the general phenomena.
Actually, if we go with this, the entire evolution. So I will take a few sensors like if you take radiometric system, spectrometers, these can be kept within the flying platform, like earlier in fixed wings, now in helicopter. Afterwards came in electromagnetism what we call is pulse transit systems or those kind of systems where this aeroplane itself is made a part of a loop and sensor is hanged below the aircraft. At present, what we do is we hang both the transmitter, the present technology of transient electromagnetism, we hang both the transmitter and the receiver something like 30 to 40 meters below the helicopter. Of course, it depends also on, we have to keep the sensor closer to the ground. One thing which is important, because if the sensor is not as close to the ground, then signal will be weak. At the same time, we have to keep sensor as far away from the flying platform, helicopter or fixed wing, because helicopter noise itself can affect. So we have to optimize between the two, but sensors are hanging. A magnetometer also hangs below the aircraft or helicopter, but spectrometers are kept within the helicopter. This is the present system.
So any specific tethering process for the sensors to hang? I think mostly I think there will be flexible hanging, means they can be changed also. The position of the sensor with the hanging can be adjusted.
We have to be very careful that the geometry of these loops or sensors do not change, because if that happens, your entire, because it's all induction process. So if the geometry changes like little bit also, all the data gets corrupted and sometimes you end up only recording noise. So what is done is basically these are cables. It's a transmitter is basically made of these power cables which can withhold the currents of something like 240, 300 amps. But these are put under a rigid frame, within a rigid frame, which is tied through a rope, bungee ropes, to helicopter. And we have to make sure that helicopter does not fly at much higher speed to deform the geometry. Or if there is a wind shear, we have to take care. Sometimes we have to abandon also the flights. So we have to make sure that the geometry of these loops don't get distorted. With our other system is SkyTem. Now there are some other things are there, like they also measure the tilt of the loop. So if normally what we do is that we try to keep loop as horizontal as possible, but SkyTem kind of systems, they have some kind of differential GPS and altimeter systems, laser systems, so they can also measure tilt of the loop and they can apply corrections for those.
Okay, thank you very much, sir. So,
you're welcome.
Yeah, so we'll move further. Thank you once again, everyone, for the talks today. It was really great listening to all the speakers and stakeholders, and was interesting to know about the technology of airborne geophysics. So we have almost reached the end of the session. I thank all the speakers and stakeholders for connecting with us today and sharing your experiences on the technology, and also the viewers for showing interest in the talks and interacting with our speakers. So with this, I invite Dr. V.M. Tiwari, Director NGRI, once again for delivering the closing remarks for the session. Over to you, sir.
So thank you, Sikha, and thank you to all the colleagues who could spare their time to join us on this momentous occasion of celebrating the 75 years of India's independence, and of course the achievements which includes the airborne geophysics initiation, development, implementation, and also utilization for different purposes. I must make a mention that when we celebrate the Azadi, so we also being reminded of the call the government of India made is for the Atmanirbhar Bharat. And for any self-reliance, the science and technology plays a very important role. And the countries like India is going to be dependent on its natural resources. And that we have learned much more during the COVID period, realizing the fact that whether the import of several naturally occurring substances were not being imported at a time because of the different constraints. We fortunately had the abundant rainfall. However, still we have large scarcity of water. And you have seen that a city which is almost at the bank of the ocean, the reservoir of water, is struggling to cope up during the future climate change of potable water availability for the city. The bottom line, what we understand from these conversations and the remarks made by the distinguished panelists from the different departments and ministries is there is a need of strengthening our capacity of exploring and exploiting in a very environmentally friendly manner of the natural resources for sustenance and progress of the country. And geophysical exploration, particularly the airborne, and Dr. Manglik has briefly touched upon the development which CSIR NGRI has initiated a project under a broad umbrella of CSIR mission project, a DREAM, drone-based electromagnetic and magnetic system, is a step towards this Atmanirbharta. And I'm very pleased that we have reached to the first step of designing and at least not commissioning, but a prototype of the instrument. We are also developing and designing the drone under the CSIR umbrella, and one of our labs, CSIR NL, is working on it. So in this regard, the remote sensing observations, whether they are at 10 meters height or they are 100 meters height, are going to play very important role. One of the recent initiatives which CSIR NGRI has taken up and is going to be deploying the drone-based. In fact, NGRI has flew again the first drone-based magnetic measurement in the country, and going to fly in the place like Ladakh, where there is a very less possibility of making surface measurements for the geothermal energy. And you must be appreciating that in present era of the climate change and carbon credit, we must have renewable resources optimally utilized and enhanced. And in that regard, again, the airborne or heliborne or other different platforms will be very useful. And with the inputs from our collaborators, our mentors and supporters like Atomic Mineral Directorate, Ministry of Jal Shakti, CGWB, as well as new infrastructural developmental programs like Rail Vikas Nigam. Probably it is important to mention that again it was the first any heliborne electromagnetic system carried out in the Himalayan terrain, and it was done by the CSIR NGRI for the project, which is, as Vijay Dandawalji has mentioned, is one of the longest tunnel project for the movement of the people. So we have covered a gamut of the applications which the Airborne Geophysics can offer. And we had the people, those who are going to make our country proud through the exploration of the uranium, through the management of the water, by smartly developing the city or connecting people from plain to the hilly terrains. So we are very much thankful to all of them, their advices, their presence, and I'm also very pleased that our colleagues have come up to the expectations in the present era, in the present day for the national priority projects. And few of them have joined today, but a very big group of the dedicated colleagues of the CSIR NGRI is formed each part of this initiative, and I compliment on this Engineers Day. I am also very pleased that we are celebrating as a part of our Department of Scientific and Industrial Research program, Azadi Ka Amrit Mahotsav, and Sika has very nicely conducted this program. So once again, I take the opportunity to thank all those who have joined as a panelist and those who have joined us through the different media, Facebook, YouTube, or MS Teams link today. So thank you. Jai Hind.
Thank you.
Thank you very much, sir, for the closing remarks and summarizing the session. So it's really a team effort at both the ends, at NGRI and CSIR headquarters. So bidding you all goodbye for now to the viewers. Stay safe and have a nice day.